Hey, what's up, guys? Welcome back to cross-platform game engine development. What we're going to do today is actually going to be a little bit simpler. We're actually going to be changing our GLFW backend into our SDL backend, and it's actually really simple to do. The reason that we're doing this is I've been experimenting around, and we're going to be looking at, in the relatively near future, extending our engine to support multiple renderers, so OpenGL as well, and also support other platforms other than just desktop. So we're going to look into JavaScript, so the web, and we're going to look at Android as well. Before we get into switching the backend, I'm going to show you a quick run through of the cross-platform playground I've been working on, which currently has JavaScript, Android, and desktop support. And I'm going to show you what it is that we're looking to move into our bigger engine and not just a single project. So let's just look at that now. So if you're interested in playing with this code yourself for this cross engine, which isn't necessarily the engine that we've been building, I've got this repository, Mobile Technologies / cross engine, where you can play around with it, and it should be relatively easy to get up and running. Now, if you're interested in learning how I kind of figured some of this stuff out, I found this great resource that I would be remiss to not share. It's called A Simple Triangle, and it's a couple of years old. And this Chad right here, he went through and actually did a very basic cross-platform engine that actually supported iOS as well. I've taken this and I've adapted it to the way I like to work personally. He uses a lot of bash scripts, and either way, this is where I got a lot of the information. I got up to about setup Windows app here, where I got all three platforms rendering just the background color. And then I actually switched over to learnopengl.com and started working through some of the OpenGL stuff. I'm actually going to be continuing on looking through this and other stuff to try getting our cross-platform Vulkan stuff working as well. So let's just look at the code real quick for this, just to show you what it looks like if you were to grab it today. It's pretty simple. So let's open it. Oh, I already have it open. Okay. So you see I have cross engine open here, and you're going to have your different target. There's one main target here, and if it's a cross engine and you run it on your desktop like this, you're going to just get you'll see it's even called a simple triangle, but it's been adapted quite heavily. You'll get a square. Now we'll leave this running. Actually, we won't leave this running. But if you want to, you'll also see that there's Android and our build script. So if we go to here, and we're in our cross-engine directory here, and you call your build web. Give me a sec. Let me restart my console. My console seemed to be a little bit screwy. And if we call build web, you're going to see it's going to activate your mscripton, and it's going to build your JavaScript directory. Now everything is set up to output to this distribution project/dist. It'll output to their own directories, and you will be able to just use them like that. So here I've got an exe, here I've got an HTML. So if you want to see what this looks like in action, you can do /serve web, and it will serve the web page at your local host. So you'll see here it gives it to localhost. And if I run that in my browser, you'll get this, click cross-engine HTML, and you'll see we get the same red square on here. And that's pretty cool. So if we run this, you'll see it's the same. Like this. See? Perfect. Now, what about Android? Android works as well. So let's just keep that page open for now, and let's open our Android Studio. Now, the Android Studio setup, you might have a little bit of work to do. Specifically, you're going to need to make sure that I have it in the README here, I think. You're going to have to make sure that you have Android NDK Home and Android Home defined. And specifically NDK, if you go to here, I don't know why this. Well, I know why. I don't know how to fix it yet. Oops, no. If you go into show package details, you'll be able to choose the version. You actually need to go back to version 20.0 because they deprecated something in 21. You could probably go to 20.1, but they deprecated something in version 21, the platforms folder, that is required, and it won't build without it. I'm still looking at figuring out how to fix that. With that all set up, though, you can just open the Android folder. So if you go to open, you do cross-engine project Android and just open the Android folder. This will give you an Android project, and you will just hit play. And when you play this, this is going to open in my simulator, so give it a second. There you go. And this is what it looks like inside our simulator. And just to prove that I'm not faking anything, if you go into this main folder here, this is shared by all 3 platforms, and you go into your shaders here, we can change the color. Let's just say we'll put this at 0.4, 0. Let's add a lot of blue, add a lot of blue, and get rid of some red. 0.0. Let's do that. Now that we got that, we can play this, and we'll just run all the platforms again. So you see here, I've got this nice bluish color. If I go to my thing here, stop serving, and build my web client, you'll see it will create the build files, and it will actually build. These apparently are no longer used, so I can remove them. So yeah, so it linked and built, and we'll serve it again. There you go. And with it serving, let's open up the website. Now, you'll notice here, if I just do a simple refresh, it's still red. That's because I need to, this looks bad. For this to work, you need to clear your cache. So if on Google Chrome, you can do Control-Shift-R to clear your cache. And I believe you can probably, here, hard reload. Hold this and click hard reload, and we'll hard reload, and we'll reload to blue. So you saw here that it switched to blue, and same thing with Android. All you have to do is hit play again. It will detect that there was a change inside the main function, and it will give us blue, or it should give us blue, assuming I'm not crazy, and it gave us blue. And that's our cross engine. Okay, so I hope you're excited to get to that point. I hope you're interested in going this direction. I personally was quite excited once I got all this working. So what we're going to do now is, since for this, the way I learned how to do it, or the way I figured it out, I use SDL, I'm going to show you how we can very simply switch out our GLFW backend with an SDL backend, and everything will work great. So let's just jump into that now. And again, don't forget to hit the like button because I put a lot of work into this stuff. So let's get into that. Okay, so first thing we're going to do is we're going to open our C++ project, our YouTube project. Notice if we go to our game.cpp, so under our engine, source platform game.cpp, what you're going to see here is that we have this, we're providing window, which is just service provide multi-platform window, right? Now, since it's this is how it was designed, it's very easy. All we want to be able to do to switch it out, really, we want to be able to do service locator provide, service locator provide, and then we do new SDL window, and that's what we want to do, right? So we could call it multi-platform window as well, but we're going to be specific here just because this one's already named this. So let's create our new SDL window like that, right? So the first thing, we're going to hit right-click on platform, and we're going to add a new class. And that class is going to be SDL window, right? And we will add that. Now let's not forget to namespace everything. Namespace Oz. And add the same thing in here. Namespace Oz. There we go. So we've got our SDL window. We'll reload the CMake project, so it gets rid of this banner at the top that says it's not part of the project, even though it's not showing up, but it generally usually does. There we go. So it's in the project. Now if we go to our game.cpp, it's not here, but it does detect it, so we can import that now. And now we will comment this out. This is going to be a red squiggle because it is not, it does not adhere to the interface. So we can actually use this as a guide for what we need. So we know we need to override pretty much all these functions, these 4 functions here, right? So let's put that in here, make sure it's inside our public. And inside, we'll also need to grab this window header. We will extend window on here. This is an SDL window. I know we're going to need it, so we're going to include SDL.h, which is not there. So that's going to be our next step in just a minute here. So we've got the scaffolding here. Let's just add all of this, generate all these functions, and then we will, there. Okay, so now we need to add SDL, right? So to add SDL, we're going to do very similar to the way we added GLFW. We're going to go to our terminal down here, and we are going to go to, if you go here, it's github.com libsdl.org/SDL. Grab that link, and we're going to add it as a submodule. So we're going to go git submodule add, and then we'll add this, and then external/SDL. So that's going to download. So we got SDL now. We now need to add SDL to our CMake file, and this is fairly simple. At the top here, right under GLFW, we will just add external SDL. In include directories, we want 2. We want SDL2 main, and we want SDL2 dash static, like that. And we will take these same 2 and add them to our target link libraries as well, like that. And with that done, we need to reload the changes in our project. So it's loading our CMake project. It's updating. You notice how all the SDL stuff has been added. And that's all we need for now. So with that done, we'll go back to our SDL window, and now we will include SDL.h. And the only reason we need that up here in the same file is because we want, in our private here, we're going to want SDL window pointer, and we'll call it window. Yep, like that. All right. Now we're believe it or not, we're actually like 90% of the way there. So now we just need to go to here. So actually here, we're getting a warning here specifically because we're not initializing this. And it's always good to, we're going to say SDL window equal default, just to give it a default constructor like that. And that will get rid of all of these warnings eventually. See, all gone. So if we look at our GLFW implementation here, and we look at open window, so we did this. So basically, I'm going to remove this today. And I'll go back to here, and we're actually just going to put an equal null pointer here, just to be explicit about everything. And here we'll just equal default again, like that. So if we look at our open window, you'll see here we initialize the windowing system, and we create the window, and everything else in this function has to do with input, right? It's all the input stuff we did last time. I'm not going to redo all this input stuff today, like migrate it over to SDL. I might do that as a supplementary video, or we might do that on stream soon. But we're going to just stick with doing this create window stuff first. So we'll start off in here. We're going to open the window. So first thing we did in GLFW, the same thing in here. We SDL init. Now, depending on what you need to do, you might need to do various things here. A lot of people will do SDL init everything, which will init absolutely everything. You could also SDL init like the event system, or SDL init the video system by itself. We're going to do everything just because I'm lazy and I don't want to figure out all the flags right now. The second thing we're going to need to do is we're going to need to keep track. We'll deal with one thing in a minute here, but we're actually going to keep, let's say, auto width equal data.width and auto height equal data.height. And now finally, we just need to create the window. So we'll pick our window and we'll SDL, create window. And not create shape window, just create window. So we want to give it the title of the window. So data.title, title.cstring. Then I believe this is the window position. Why? I'm having issues typing today. I'm kind of off center right now. Yeah, so this will be the position. So we want SDL window position centered for both X and Y. SDL window position centered. And then the width and height, and the flags. The flags themselves, there's going to be two flags. One, we want to tell it it's Vulkan. So we're going to say it's a Vulkan window Vulkan. And we also want to tell it that it's shown. And it's not a hidden window, like that. And that's everything we need to do in our open window function. So I'm actually just going to break this up into 2 lines because it's past this 80 character limit suggestion. So update is very simple as well. If you look inside here and we go to our update function, all we're doing is we are polling for events, and then we are checking to see whether the window was had requested to close, right? And this returned true when the window wanted to close. So we're going to do the exact same thing, but it's a tiny bit more involved here. So what we're going to do is we're going to say SDL event like this, event. Then we are going to poll for the event. And remember, our update is actually already in a loop. So SDL poll event and event. So now that gives us the event. And now generally we'll do stuff with event. And what we're actually doing here is we're doing an if event.type equal SDL quit. Then we're going to return true, telling the game to quit. And otherwise we return false, saying no, we didn't request to quit, and that's what we need. We're going to skip get window extents for just a minute here, and we're going to go to request draw surface. Now, if you remember correctly, let's just look here, find usages. Yes, base function. So if you remember here inside our Vulkan renderer in our core, we actually it actually sends it a surface and requests the surface from the windowing system, right? We need to handle this now. Without giving this, our Vulkan renderer won't be able to connect to our new window. So this most simple way to do it, because we've already done it before, is we'll actually just copy the block we have inside our request draw surface in our GLFW one, and we'll copy it over. Now remember what's happening here. If you we'll deal with these errors in a second, but what's happening here is that the renderer has sent in these arguments into request draw surface, and we are just extracting these pointers, casting them into the thing we want, and then populating them with our window, right? So it's actually a very similar process that we're going to be doing in SDL. So first thing we do, we need the Vulkan. So SDL has its own way to include Vulkan. So it's going to be include SDL, SDL underscore Vulkan here. Now, when we get to OpenGL, there's probably going to be like an if OpenGL or something like that here. But we're not going to worry about that quite yet. So we're going to include our SDL Vulkan like that, and that will bring everything in. VK null handle. It's weird that that's not there. So let's also include Vulkan H, just so we can get all of these red things gone. Now we want runtime error as well. I believe one errors. No. IOStream. I think IOStream brings it in. Yeah, IOStream brings in runtime errors, which is fine, and that's all we need. So we don't actually need this callback now. So you notice how in GLFW create window surface, there was these allocation callbacks. We have a very similar function, SDL create, what is it? It's Vulkan create surface. And then it doesn't have, if you look here, it doesn't have, it takes an instance, it takes a window first, then it takes an instance. So we give it our VK instance, and it doesn't take a callback, and then you need to give it the surface, right? And this will return an enum SDL bool. So we can say SDL true. So if it's not SDL true, which I imagine means fails, we will throw a runtime error. Otherwise, we will continue on as normal. So notice how we don't use this anymore, so we'll just remove it to be clean. And there we go. Now, we have one last thing to take care of here, and this is this get window extents. And this is, we'll look at it again just so you can see where it's being used. When we create our swap chain, you'll notice here, when we create our swap chain, what we're doing is we're getting the window's drawable surface size, and we are then storing it and using it to create our frame buffers and our images and everything that Vulkan is using. So we will do the same thing here, not the multi-platform window, SDL window. So inside here, I believe there's a new function called SDL Vulkan get drawable size right here. And what we will do is we'll say int width and height. And in here, we give it the window, we give it the width, and we give it the height, like that. And then we will return this as a pair, as width and height. And believe it or not, that I believe is everything we need to do to have SDL rendering our window. And except for the fact that we do not have, we are not handling input in our SDL window at this time. So let's hit build and see what happens. All right. So notice here how it builds, and if we hit play, we should get our triangle just like that. And this is being rendered with SDL, right? So if you look here, I believe last time when we were here, let me just look here, we added some input managers, right? So we had it so that if we were strafing left and right, WASD, right? Yeah, we had actions A and D. So we had A and D, and we were able to strafe. So we had it so that if we had A and D like this, which it won't be working now because I don't have it, A and D, that it was throwing actions, right, on our GLFW window. So if we comment this out and we put our GLFW window back, we should get that functionality back. And notice how even though we switched the window and we no longer have an input manager, see, notice how it's doing strafe. We've switched the windowing system and we no longer have an input manager inputs registered through it. We do still have our rendering. So this is the main, what I just showed you was actually the demonstration of the powerful way that abstracting everything out into an interface and hiding your implementations makes it so that you're able to just switch out any system you want whenever you can, right? So if I want to switch the input system to come from SDL or come from my VR headset or any of that, I'm not stuck to GLFW because the public interface that we defined knows nothing about GLFW. So for now, what we will do is we will keep it SDL window, and I'm just gonna leave this commented out here because we might it might be interesting to just keep both in there, right? And see where we run into limitations. And it's very possible that doing this setup, we'll figure out how to do cross-platform with GLFW together. And because I personally think GLFW is a little bit more lightweight. So if we can manage that somehow, that would be great. All right, so that's some pretty exciting stuff. Was really easy to do. I was actually surprised. I expect that to take much longer. It actually took me much longer to move the cross-platform playground that I was making into Windows and get that compiling properly before it took longer to do that than it did to just switch to SDL inside our game engine, which I'm happy that worked out as easily as it did. It kind of validates the design a little bit for me. So anyways, if you enjoyed that, be sure to hit like, subscribe, comment down below, all that crap. And in the next lesson, we're going to go over vertex buffers, probably maybe some index buffers, and start making things a little bit more interesting in our project here. And when we get down that road, we're going to be able to hopefully start moving stuff around the screen, which would be pretty cool after how long this has been going for. So anyways, thanks for sticking around. See you later.